So, welcome to this lecture of subcomputing techniques. So, in this lecture, we will try to understand the basic definition of subcomputing and its parts, and we will try to understand the fuzzy sets. Why the subcomputing approach? Mathematical models and analysis can be done for relatively simple systems. However, more complex systems arising in biology, medicine, and management remain intractable to conventional mathematical and analytic methods. Subcomputing deals with imprecision, uncertainty, partial truth, and approximation to achieve tractability, robustness, and low solution costs. It extends its application to various disciplines of engineering and sciences. The term subcomputing was proposed by the inventor of fuzzy logic, mathematician Lord P. A. Jade. He described subcomputing as subcomputing is a collection of methodologies that aim to exploit the tolerance for imprecision and uncertainty to achieve tractability, robustness, and low solution cost. Its principal components are fuzzy logic, neurocomputing, and probabilistic reasoning. Subcomputing is likely to play an increasingly important role in many application areas, including software engineering. The role model for subcomputing is the human mind. Basically, there are many components in subcomputing. Components are, as I told, components are fuzzy logic, genetic algorithm, graph set, neural network, etc. So, subcomputing is not just a mixture of these ingredients, but a discipline in which each parts contribute a distinct methodology for addressing problem in its domain in a complementary rather than the competitive way. There are many characteristics of subcomputing. Some characteristics of subcomputing are it does not require any mathematical modeling or problem solving. It may not yield the exact or precise solutions. Algorithms are adaptive. It can adjust to the change of dynamic environment. So first components of subcomputing is fuzzy sets. Let's try to introduce the fuzzy set to you. Before introduce the fuzzy set, let me talk about the creep sets, which are the simple set. So creep sets, as you know, the simple set or creep sets is set is a collection of well-defined and distinct objects. So well-defined means the term should be defined well. If I say the set of a good students, so that is not the creep set. So creep sets, our set theory will not enough to define the set of good students. It also cannot define the set of red apples. So apple may be different colors, some red, some green. So there is some limitations of the creep sets. To remove this, to deal with this limitation, we introduce the fuzzy sets. So first, that Lotfi A. Jade introduced the fuzzy sets in 1965. So what is fuzzy? It's a dictionary meaning of fuzzy which is not clear. Okay, something daisy, not clear. So try to understand the example which I told you right now, the set of a good student. So we are trying to understand the set of a good students. Okay. So this surely is not a set of a good students. Set of good students. Set of good students. So the term good is not properly defined, is not well defined. So we can express the this as a creep set. So it is now we have introduced the fuzzy set. So fuzzy sets, along with that, there is a something term. So simple set, you can say the creep set, simple set that can be right is a just like a number 1, 2, 3, 4. So that is simple number. But fuzzy sets, it's a order pair. Fuzzy sets, this is a order pair. Suppose you need to write something like 1, order pair, something like 1, then some number 0.1, then 2 maybe 0.2, and so on. So that is a fuzzy set isn't basically order pair. So first is number, and the second part the number x, and second part is mu x. So mu x is known as the membership functions. Functions. Mu x is known as membership functions. Okay. So the mu x is known as the membership function. So some characteristic of mu x is that mu x is always lies belongs to 0 and 1. Okay. If it is 0, if it is 0 means not belongs. If it is 1, then uh, it is surely belongs to that set. So now try to understand some example that as I said the good students. So every student is associated with some GPA. So we are writing GPA is 1 to 10. So we are dividing it 1 by 10 of GPA. If GPA is 10, then it's 1. GPA is 8, it is 0.8 like that. Okay. So now what is the fuzzy set? Set of all good students. Fuzzy sets, which is the set of good students. Set of good students. So we can write it just like that. Suppose student S1 score 10 GPA. So I am writing it 10 by 10 1. If students 2 score 8 GPA, we can write like 0.8. If students S3 score 7 GPA, so we can write 0.7, so on. So that we define the fuzzy sets. Okay. The say element and the membership function. You can write the fuzzy sets is something like xi and mu of xi. Mu xi belongs to 0 to 1. So this the thing of the fuzzy sets. Let take another example of fuzzy sets. Like as I said that set is that colors of apples. Okay. Let color of apple. Color of apple. So let mention the set the apple of red color. Take apple color of apples. So we are writing that the let a fuzzy set. Suppose the set 2 or fuzzy set 2. It defines the set of red color apple. Set of red color apples. Okay. So there said some maybe red color, maybe some red, some portion. So let the apple 1. So it is absolutely red. So it GPA is a 1. Membership function 1. Let it 80% apple to 80% red, 20% green, or some other color. So this 8 to maybe some colors no absolutely green color, so it should be sub apple 10 absolutely green color, so it will be 0 no red color. So this is the example of the fuzzy sets. Okay. So now try to understand one important thing is that suppose we are saying that uh, we are saying that set of red color we want to convert it from fuzzy to creeps. We want to fuzzy to creeps. So the fuzzy sets which membership functions are absolutely one like A1 set of red color. Set of red color, this A1 also belongs to the creep sets because its membership functions 1. So in creep sets there are only two values. Either it is 0 or 1. If it is value, membership value is 0 of the element, it does not belongs to the set. If it is 1, it surely belongs to the set. But for the case of fuzzy, membership value lies belongs to 0 to 1. Lies belongs to in the interval 0 to 1. So I hope the you understood the fuzzy sets and creep sets. So creep sets, basically there are only two value, either 0 or 1. Okay, 0 means belongs to the set. If it is 0 means not belongs to the set. If it is 1 means belongs to the set. Whereas the fuzzy something 0 to 1, the membership value 0 to 1. Okay, so let me try to explain one more things. Okay, so basically, what in the creep sets? Suppose we are trying to example of some students' grades. So basically, if the students lies belongs to the grade of, suppose you are assuming that 90, 90 to 100, then students will get A plus. If it is students are something like, okay, so let it 91, 91 to 100, it get A plus. Okay, 91 to 100 A plus. Let students GPA is from 81 to 90. It is A. Okay. Students GPA is something like, you can check other also. Let one more options. Let it's from uh, 71 to 80. Then you got B plus. Okay. So we're dealing with only three. So their boundary in the creep sets boundary are very strict. Suppose this is we start with the 71. So 71 to 80. So this in this interval, all the students belongs to B plus. In this interval, 81 to 90, all students belongs to A. And 90 to 100, all students belongs to A plus. 100, all students belongs to A plus. So here boundary are very, very strict. So for creep sets, boundary are very strict. Boundary boundaries are very strict. Okay. Now try to understand one thing, that the students are 79, or let the students score 90 or 89. Here getting the grade A. If the students are getting 91, getting A plus. So only 2 marks. The grade is changed a lot. Okay. So now, so there is, you can say that is also in real situation only 2 marks the grade is changing. So this is it's real life situations. Though this happen, but what I am going to say, that is it logical that only 2 marks we are changing the grades? So in fuzzy sets, it's not like that. Fuzzy sets is that it will tell like these things. Here boundary are soft basically. Now how to introduce the fuzzy sets in this interval? So try to understand. So now 71 to 100. Okay, 71 to 100. So we need to define some membership functions of the grades. Okay. So those who are 70, so let the grade gives him something, grade gives something A, B plus. Okay. So something give B plus. So we are trying to understand these things. Try to understand here. Suppose this is 80. Okay. This is 90. This is 100. So let something like that. diagram. Okay. So students score something like you score 75. 75, let's assume 75. For this 75, the students score B plus 50%. You can check B 50% B plus and 50%. This is the portion B plus. This is A. This is A plus. So the students who got 50%. So let's just get 75. So its 50% weightage belongs to B plus and 50% weightage belongs to A. If it is 71, then surely 100% B plus. If something like 78, assume that 78 months. This is for 75 months. Let something 78. So it depends on the value that equation need to find straight line. We'll do it later. So now 75. So let it is a 0.75. Okay. So 0.75. Here the value of 0.75 value A plus. This line belongs to the A. Okay, this line is belongs to the B plus. So now number is here. So we can say 78, or you can check the number which is 77.5. Okay. So 77.5 you can write 70% is belongs to A grade and 25% belongs to B plus. So this is the basically the fuzzy sets. Okay. So in the case of uh, fuzzy sets, boundary are very soft. So in the case of fuzzy sets, boundary are very soft. Okay. Fuzzy sets, boundaries are very soft, not just hard as the creep sets. So in real life, it is more logical. Okay. So these are the concept, the relations, you can say the comparison between the fuzzy sets and creep sets. Let's summarize once more. There's some elements which are surely present. I mean, again, I'm saying that for the set of creep sets, if it is present, then it is 1. 1 for the set belongs present on that set. And if it is 0, means not present. So this is the concept we have in the fuzzy sets. What are the creep sets? What are the fuzzy sets? The perfect. This is depends on the membership functions. So if it is not present, membership is 0. If it is 25% present, so membership will be 0.25. If it's 35%, then 0.3 and so on. If 100%, then it is 1. Okay. So you can check one thing, that these some numbers, that f belongs to fuzzy sets. So these are the some number. 1, suppose it is 0.1. 2, membership is 0.2, and so on. Let 10, the membership is 1. So this is the fuzzy set, the number in the membership function. So if it is right creep set, so the only one number present which membership value is 10. So this is the creep set. Okay. So let I hope you have understood the thing, the creep sets and the fuzzy sets, and also the importance of the fuzzy sets. So try to understand that in all real life, suppose somebody asks me how are you, so it's not like creep sets. I can, it's like maybe I am happy, so it's maybe may not be, sometime happy, sometimes sad. So in every situation you will get the fuzzy sets, not the creep sets. Okay. Okay, so let try to understand some examples of the membership functions. Okay, so as I told you that the fuzzy sets, there is some membership functions. So let this is some x, and mu x, this is always lie belongs to 0 to 1. Okay, so derive anything. Suppose it is point is 1. Suppose the point is this point is 5. Assume this point is 5. Assume this point is 10. Okay, and so on. So let the membership value 1 is there, 10 is also 1, 10 is also 1. So this is one type of fuzzy sets. Okay. So let it is 15. Okay. Okay. So the point you can say this is 5 comma 1. It point you can say it is also the 10 comma 1. Now how to define the fuzzy sets? Here fuzzy set is let this state line. So you can find the state line equation. So how to find the members functions? So find the equation of the state line. So how equation find, you can say that 0 0 point and it is the 5 1 point. So you can write the equation like y minus 0 equal to 1 minus 0, 5 minus 0 by x minus 0. So you can write y equal to x by 5. Okay. So here you can say the fuzzy sets. Suppose the value is 1. Okay. 2, 3, 4. So for 1 membership you can write 0.2. For 2 you can write 0.4. For 3 you can write 0.6. For 4 you can write 0.8. For 5 this is 1. So this is the now. So 5 to you can write that membership functions mu x equal to x by 5 if x belongs to 0 to 5. You can find it 1 if x belongs to 5 to 10. Now it's equation of something like that, it is 10 0. So you can write it 15 0. So here if you find the equation you will get it y equal to. So just calculate the equation again for these membership functions. So you'll get something. So that will become the membership. So from this graph we can find the uh, membership functions. Okay, so this is your task. You calculate the membership functions when it is from 10 to 15. Next, try to understand the support of a fuzzy sets. Okay, so there are few terms. Try to understand the support of a fuzzy sets. So these are the fuzzy sets as I draw the diagram. So you can write like this, any other diagram. Okay, so that is the x element x. This is mu x. Mu x is always lies belongs to 0 to 1. So let this point is 1. So okay. So fuzzy set is what? Fuzzy set is x mu x. You know how to find x and mu x. Okay. Support of a fuzzy set. So definition of the support of fuzzy sets is that support of a fuzzy set A. So this is a fuzzy set. So support of a fuzzy set A. Support of a fuzzy set A is the set of all points which mu x is greater than 0. Mu ax greater than 0. I mean that numbers, not 0, greater than 0. Okay, so you can write support of A is equal to x. This is number x. This is creep sets. Mu x is greater than 0. So that is basically the support of a S. Okay. So it's for example, if I take that uh, let some A is the fuzzy sets, something like 1, as I said 0.1, 2, 0.2 and so on. So support of A, all numbers having greater than 0. Okay. Support of A is just like 1, 2 and all the numbers for which membership function greater than 0. So that is the known as the support of a fuzzy sets. Okay. Now core of a fuzzy sets. So core of a fuzzy sets. So the core of a fuzzy sets core of a fuzzy sets A is the set of all points set of all points x in X such that mu ax equal to 1. Mu x equal to 1. So again core of A is equal to x, mu x equal to 1. So if I take that example, just like this example, so this part is the core A where mu x is the 1. Though this part is the core A where mu x equal to 1. Now a fuzzy set A is said to be normal. A fuzzy set A is said to be normal. A is normal if its core is non-empty. If its core is non-empty, means always you will find an element x for which mu x equal to 1. Okay, so always there exists x for which mu x equal to 1. So for the normal set, you will get at least one element which can you convert it to the creep sets. So that is the concept of the normal. Okay, so core fuzzy and normal. Now try to understand the bandwidth of a fuzzy sets. Okay, so bandwidth of the fuzzy set basically uh, the thing is that this is the fuzzy sets. Suppose this is x, this is mu x. So mu x is 0.5. So here is the mu x is 0.5 and something here is the mu 0.5. So let it is x1 that equal to x2 such that mu of x1 equal to 0.5 and mu of x2 also equal to 0.5. So these points are known as the crossover points. Crossover points means a crossover point is a fuzzy is a set A crossover point in fuzzy set A in fuzzy set A is the x with membership function is 0.5. So here you can say x1, x2 are crossover point. So what is the bandwidth then? Bandwidth is that the difference between x2 and x1. So bandwidth is bandwidth is the difference between these two crossover points. So bandwidth is equal to mod of x2 minus x1. Okay, where x1, x2 are the crossover points. Okay. So in this lecture, we have seen the things which are the what is the need of soft computing. Need of soft computing. Second is that what is the fuzzy sets and its difference with a creep set. So fuzzy set versus creep set. How to find membership functions. Second is the different terms of membership function, just like core. First we learn support, then we learn core, then we learn normal fuzzy set, then we have learned the crossover point, then we learn the bandwidth. Again, so try to understand fuzzy sets and question is that so From your real life situations, try to make 5 examples of fuzzy sets. Question is that from your real life, from a real life, you find or you whatever say define 5 fuzzy sets. 5 fuzzy sets. Okay. So these are the reference for the today's class. So thank you.